So Unit 13, we're going to start off looking at solving rational equations. So in the last unit, Unit 12, we looked at how to simplify rational expressions, how to multiply them, add them, subtract them. So now we're going to be looking at equations, which means we have an equal sign over here. So we still have the fractions, that's what makes these things rational, okay, but now we're going to have an equal sign thrown in. So these are examples of rational equations. Just a rational added or subtracted to another rational. It doesn't necessarily have to have addition or subtraction. Okay, this would be a rational equation as well. I've got a rational expression equal to another rational expression. So those are looking at rational equations. Okay, we're going to have something that comes up called extraneous solutions. This is something we have seen before. Okay, but an extraneous solution is a solution that is found but does not work in the original equation. So on these ones, you have to check. There is no maybe or kinda or something like that. You absolutely have to check these because you can get solutions that are actually not solutions at all, and we call those extraneous solutions. Okay, so if I want to solve something that looks like this, the easiest way to go about it is to figure out what your common denominator is for all of your denominators. So I've got 2, 3, and 6. So between 2, 3, and 6, my common denominator would be a 6. Okay, so I'm going to go through and I'm going to make common denominators. So to make a 2 a 6, I multiply by 3, top and bottom. To make a 3 a 6, I would multiply by 2, top and bottom. And a 6 is already a 6, so I don't have to do anything there. Okay, so from there, go ahead and multiply out your numerator. So I've got 3x over 6 plus 16 over 6 equal to 1 over 6. Once all of your denominators are the same on both the left and right hand side, you can actually just cross this out. Okay, let me explain why. Because if I wanted to get rid of the 6 on bottom, I would multiply everything by 6. Well, if I multiply everything by 6, I would get 6 over 6, 6 over 6, 6 over 6. All the 6's would cross out anyways. So, if I have, and this only works with equations, this doesn't work in the last unit where we did expressions, but if I have equations and all of my denominators are the same, I can get rid of my denominators. Once that's done, these are very simple equations. 3x plus 16 is equal to 1. You just solve for x. So minus 16, not 15, minus 16. Helps if I can write. Okay, minus 16, 3x is equal to a negative 15, divide by 3. X is equal to negative 5. Now, once I get here, man, I am not writing correctly. Negative 5, 15 divided by 3 is negative 5. And once I get here, I do want to check it. X is equal to negative 5. You would plug that in. Negative 5 halves plus 8 thirds does equal 1/6. You can toss that in your calculator and do that very quickly. Okay, but you do need to actually check these things to make sure that they are solutions. And we'll talk more about when it's possible that it won't be. Here, there's no way it's not going to be. The only time, let me just talk about it now. The only time that it's not going to be a solution, or it's possible that it's not a solution, let me rephrase that. The only time it's possible to be extraneous is if there is an x in the denominator. Okay, so for instance here, I have an x in the denominator. So it is possible that it could have an extraneous solution because you cannot divide by 0. So we have to consider the fact that if it makes the denominator 0, then it's not going to work. So do keep that in mind, that if I'm going to have an extraneous solution, it will potentially show up where the denominator there has an x value in it. So, and we'll look at those as we go along. Let's go back to here. Okay, so now I've got another one. So example 2, we have these here. Okay, we have to get a common denominator first. So between 2, 9, and 18, my common denominator would be 18. Okay, so common denominator of 18. So we need to make a common denominator all the way across. So to get a common denominator here, we multiply by 9, top and bottom. Make sure whatever you do to the bottom, you must do to the top. Here I would multiply by 2, top and bottom. And here 18 is already done. So here, make sure you're distributing. This is 9 times the entire thing, t minus 4. So I get 9t minus 36 over 18 minus, again, I'm distributing. I get 2t minus 6 over 18, and that's equal to 5 over 18. All of my denominators match up, so I can just get rid of them. And I have all of this on top. Now, be very careful with those minus signs. You have to distribute that negative. So we'll get 9t minus 36 minus 2t plus 6 equal to 5. Combine your like terms. 9t minus 2t is 7t. Okay, careful not to multiply here. I saw that a lot happen in the last unit. Okay, that's 7t, negative 36 plus 6 is negative 30 equal to 5. Add the 30 over. 7t is equal to 35 divided by 7. T is equal to 5. Okay, again, there are no x's on the bottom, so it's not going to be extraneous, but if you get confused on when it could be and couldn't be, just check everyone. Toss that 5 in there. 5 minus 4 is 1/2. 5 minus 3 is going to be 2 over 9. 1/2 minus 2/9 is 5/18. Again, toss it in your calculator. It's very quick. You can check it. Just make sure, all you have to do is one side and make sure it adds up to the other side. Okay, so example 3. Here we've got that variable down in the bottom. So we're going to have to worry about that extraneous solution. Now we'll have to check at the end and make sure. Common denominator. You have to imagine that if these are whole numbers and we're dealing with fractions, we throw those whole numbers over 1. Okay, just like we would in simple fractions, we're going to do the same thing with the rational equations. So my common denominator here between x and 1 is just x. So everything, and I do mean every single term, is going to have an x except for the one that already has it. So times x, top and bottom, times x, top and bottom, times x, top and bottom. Okay, now everything has an x. We've got 3x over x minus 6 over x equal to x squared. X times x is x squared over x plus 8x over x. Now please don't come to this part and start canceling stuff, okay? That would take us right back to where we started, and we don't want that. We want all of our denominators to be the same. Once they are gone. Okay, and if you were wondering, couldn't I move this 3 over first or the 8 over to the other side first? You could. You absolutely could. I could have subtracted 8 over or subtracted 3 the other direction. That would be perfectly fine as well. That's going to happen here in this next step anyways. I've got 3x minus 6, which is equal to x squared plus 8x. X squared plus 8x. Okay, so now I'm going to have to get everything over to one side. I've got an x squared. Okay, anytime I have an x squared, that means this whole thing needs to be set equal to 0 so that I can factor and solve. So here comes that factoring again. Factoring's not going away anytime soon. Okay, so we're going to subtract 3x from both sides. This is putting it in standard form. If you need to make a note, write in standard form. Okay, and again, I'm writing it in standard form because of that x squared right there. Okay, so minus 3x to the other side plus 6 to the other side. I'm going to go ahead and do both of them at the same time. So I get 0 is equal to x squared plus 5x plus 6. Okay, now I'm set up. This is standard form. Technically equals 0 is usually on the other side, which is fine. Okay, factor this. Target product, target sum. Target product is 6. Target sum is 5. Two numbers that multiply to 6 but add to 5 would be 2 and 3. Okay, set each one equal to 0 and solve. X plus 2 is equal to 0, so x is equal to negative 2. And x plus 3 is equal to 0, so x is equal to negative 3. Okay, negative 2 and negative 3, and then you would make sure that that does not give us an error or a no solution or anything like that. 6 over negative 2 is going to be negative 3, so 3 minus the negative 3 would give me 6. Negative 2 plus 8 is positive 6. That one works. Okay, try your next one. Negative 3, that would give me positive 2. 3 plus 2 is 5. Negative 3 plus 8 is also 5. So they both check. So they are both good answers. Okay, so negative 2 and negative 3 would both be your answers. So in example 4, same sort of thing's going to happen, okay, as we did in the last units. If I want to find a common denominator, I must first factor the denominator. Okay, factor the denominator. The other ones we didn't have to because there was nothing to factor. Okay, now we have a denominator to factor. So this is going to factor to x plus 5, x minus 5. This has got an x minus 5. This has got an x plus 5. So this one, okay, needs the x plus 5. Top and bottom. This one here needs the x minus 5. It's got a plus 5. We need an x minus 5. Okay, x minus 5. Top and bottom. Multiply that stuff out. So I've got 4x over x plus 5, x minus 5, plus distribute 2x plus 10 over x plus 5, x minus 5, equal to 1 times that stuff is x minus 5 over x plus 5, x minus 5. All of my denominators are exactly the same, so they all go away, which is very nice because now it's just 4x plus 2x plus 10 is equal to x minus 5. Now from here you just combine your like terms and solve for x. 4x plus 2x is 6x plus 10, x minus 5. Subtract your x over. Notice I'm not doing standard form here because I don't have a square. I only do the standard form if I have x squared, but I don't, so I'm just going to move stuff over. And we're going to move the 10 the other direction. So I get 5x is equal to a negative 15 divided by 5. X is equal to negative 3. Okay, we do need to try that. And again, really you're only looking for is does it make the denominator 0? Okay, if it makes the denominator 0, then it's going to be an extraneous solution. So you do need to check for that. Negative 3 squared, 9 minus 25, not 0. Negative 3 minus 5 is negative 8, not 0. Negative 3 plus 5 is 2, not 0. So you don't really even have to solve the whole entire thing. You can plug it all in your calculator, just make sure it works. Okay, if it doesn't work in your calculator, it's going to tell you error. Okay, it's going to tell you error. So you have to be very careful with that. Okay, so x is equal to negative 3. That is your answer. It is a good answer. So, looking at the next one, same sort of idea. Okay, I've got whole numbers here, so I need to put them over 1 first. And now this one needs an x minus 2 top and bottom. This one needs an x minus 2 top and bottom. Okay, these two already have x minus 2, so that's great. Let's multiply this out. So I get x squared minus 2x plus 14. Sorry, let me jumping ahead of myself. Minus 2 plus 14 over x minus 2 equal to 7x over x minus 2 plus x minus 2 over x minus 2. Okay, that's doing each and every one of these terms. All of my x minus 2's can go. So I get x squared minus 2x plus 14 equal to 7x plus x, not 8, plus x minus 2. Okay, from here I have a square, so that means I'm going to have to get it into standard form. Okay, we're going to have to go to standard form. So I'm going to, this is actually 8x, right? 7x plus x is 8x, so I subtract 8x over. And I'm going to add my 2 over. So I get x squared minus 10x plus 16 equal to 0. Now we need to factor. Okay, so my target product is 16. Target sum is negative 10. So that would be negative 8, negative 2. That would multiply to 16, but add to negative 10. So x minus 8 and x minus 2 equal to 0. Take each one of those, which I'm going to do over here. X minus 8 is equal to 0, so x is equal to 8. X minus 2 is equal to 0, so x is equal to 2. Okay, now we have to try them. Okay, take your 8. Again, we only care about the denominator. If I put 8 in there, 8 minus 2 is going to give me 6. Same thing there. So the 8 is good. It works. 2, on the other hand, if I put a 2 in there, 2 minus 2 is 0. Okay, that would give me a 0 in the denominator. So it is going to be extraneous. Okay, extraneous. Screen froze, hold on. Okay, so x is equal to 2 is going to be extraneous solution. Okay, yes, you do have to write that it's extraneous. You can't just leave it because it's not really a solution. Okay, it is something that we get, but it's not actually a solution. It's going to be extraneous because when I plug it in, I would get a 0 in the denominator. And you might want to make a note. Give 0 in denominator. Okay, gives a 0 in the denominator. Can't divide by 0. That's like the biggest math no-no ever. Never, ever, ever divide by 0. Okay, so 6 is going to look pretty much the same. We've got to start by factoring. Okay, start by factoring first. So here, my target product is negative 28. My target sum is negative 3. My two numbers would be negative 7 and positive 4. So this is going to be x minus 7, x plus 4. Notice that it kind of goes with these ones on the side. Okay, that's not necessarily true in mathematics in general, but in this particular class, it's a pretty good hint that you might be looking for numbers that look similar to those. Okay, not necessarily always, but it does happen most of the time. So this one's got a 7 and a 4, so this one needs a 4, x plus 4, top and bottom. This one needs an x minus 7, top and bottom. So here I've got x squared plus 4x over x plus 4x minus 7 minus 11. That one doesn't even change, right? We didn't do anything to it, just factored the bottom. Equal to x minus 7 over this whole thing, x plus 4, x minus 7. All of my denominators are the same, both sides of the equal sign, they all go away. So I get x squared plus 4x minus 11 equal to x minus 7. Don't try to solve it from there. We need to go to standard form. I've got an x squared, which means this stuff needs to come join, plus 7. Those go away here. I get x squared plus 3x minus 4 equal to 0. Target product, target sum, target product is negative 4, target sum is positive 3. So 4, negative 1, x plus 4, x minus 1 equal to 0. Take each one, set them equal to 0. X plus 4 is 0, so x is equal to negative 4. X minus 1 is equal to 0, so x is equal to positive 1. You have to check those. Okay, absolutely must check those. X is equal to negative 4. If I plug it in, I would get 0 times something. That would give me 0 on bottom, so this one is extraneous. Now you can just write ext, that's perfectly fine. Okay, you can write ext because that's perfectly fine. So that one's extraneous. X is equal to 1, that would be 1 plus 4 is 5, 1 plus 7 is negative 6, so that one is good. I believe that is it for section 7.5, which is solving rational equations.